In Modular 19, we're going to be discussing visual organization and interpretation. Much of this deals around the psychology known as Gestalt psychology. We're going to be looking at explaining how figure ground and grouping principles contribute to our perceptions. Binocular and monocular cues help us see three dimensions, how perceptual constancies help us construct meaningful perceptions, and what research on restored vision, sensory restriction, and perceptual adaptation reveals about the effects of experiences on our perception. So, what is Gestalt psychology? In essence, it is the whole is greater than the sum of its parts. And so we're given a cluster of sensations and we tend to organize them into meaningful forms. So the brain does more than just registering information. Our brain uses our memory to filter in information, and therefore we construct perceptions. So it is the interpretation of what we see that matters. So what is it that you see in this next picture? This is referred to as the Necker cube. If you see a cube, you're seeing the whole. If you see 8 hearts, you're seeing 8 blue circles. So therefore, the perception of the whole is greater than the sum of its parts. So we organize our sensation into perceptions. We filter sensory information and infer perceptions in ways that make sense to us. So what is our first perceptual task? We perceive any object as distinct from its surroundings. Case in point is, do you see the vase or do you see vases? So what is the second task that we have? We organize into a figure into meaningful forms. This is called grouping by Gestalt psychologists. We apply even as infants, even in our touch perceptions, illustrate how we perceive the whole differs from the sum of its parts, rather as water differs from the hydrogen and oxygen parts. So how do we do this? We do it through proximity, continuity, and closure. So let me demonstrate how we do that. The first one is proximity. What do we see here? We don't see 3 or 6 separate lines. We see 3 sets of 2 lines. This is how we see proximity. Another way is continuity. Continuous patterns rather than discontinuous ones. We should be able to see a series of alternating semicircles, but we perceive it as 2 continuous lines. The third is closure. We like to create completions. We don't like gaps. So we see the whole object. So our mind draws the lines. This is why we saw the B when it was with all the letters and not a 13. So here's a weird way of looking at it. Check out this next picture. You see a man who's created a house with dogs playing around it. So how do you see closure and continuity involved in this picture? Well, if you take the man and the dog and you just see the house out, what do you see? Let me go back and show you that again. This is the same house. Even though the dogs One dog seems to be hanging on the top, and so on. So what is depth perception? Depth perception is the ability to see objects in 3 dimensions, although the images that strike the retina are 2 dimensional. It allows us to judge different distances. One way of looking at this is called the visual cliff. And the way that we're able to understand is we take children and put them on a model of a cliff with a drop-off area, and are they able to see depth? So 16 to 14-month-old infants are placed on the edge of the cliff and coaxed by their mothers to crawl out on the glass. Most infants refuse to do so, indicating that they do perceive depth. There are a couple ways in which we see the world. One is through what we call binocular cues. They help us judge depth. This is through retinal disparity and convergence, as they depend on using 2 eyes. As objects become closer or farther, both binocular cues operate to help us judge that distance. Because our eyes are 2.5 inches apart, our retinas perceive different images of the world. So what is retinal disparity? So this is the way we're able to see and test our binocular cues. How does 3D images work? They stimulate or exaggerate retinal disparity, photographing a scene with 2 cameras placed a few inches apart. The 3D glasses allow us to view left field with the left eye and right field with the right eye, which we discussed in our previous unit. How about binocular cues? How does that help us judge depth? We perceive vertical dimensions longer than identical horizontal dimensions. For example, the Arc of St. Louis appears to be taller than it is wide, but it's actually the same. Retinal disparity won't help us here because there won't be much difference between the images cast on the right and left retinas. So distances, we depend on monocular cues, depth cues available to each eye separately. Here are some examples. Looking at relative height. The objects that seem higher are further away and lower that are closer. Or relative size. Objects that are smaller seem to be further away. Larger are closer. Another look at it is interpositioning. When one object partially blocks our other, we perceive it as being closer. So therefore, in this picture, the deer blocked the tree trunk. So the tree trunk seems to be further away. Depth cues make this picture happen. How about relative motion? Objects that are stable appear to move. Things we are fixated on move backwards. The further from what we're fixated on moves faster. Have you ever been driving in your car and the moon is out and it seems the moon is moving with you? This is what relative motion refers to. How about linear perspective? Parallel lines appear to meet in the distance. The sharper the angle of convergence, the greater perceived distance. Shadow and light. Shading produces a sense of depth consistence with our assumption that light comes from above. In the inverted view, the hollow will become a hill. Another perception is what we call stroboscopic movement. This is called the phi phenomenon. Normally, our brain computes motion based on the assumption that shrinking objects are getting smaller, enlarging objects are approaching. We use bottom-up and top-down processing to discover the phi phenomenon. All right, thanks. What about this picture demonstrating the stroboscopic movement using the phi phenomenon? Perceptual constancy is a top-down processing that recognizes objects without being deceived by changes in the color, brightness, or shape or size. Regardless of viewing angle, distance, and illumination, we can identify people and objects quickly. Color constancy. We perceive lightness depends on our relative luminance, the amount of light of an object reflects relative to its surroundings. There's also brightness constancy. The color depends on more than just wavelength. Color comes from the environment as well, light reflected by surrounding objects. Then we have shape constancy. We see an object as having unchanging shape even while our distance from it varies. And then we also have size constancy. Sometimes I wonder, what is that frisbee getting bigger? And then it hits me. How does the Ames room alter our perceptions? This uses those things that we talked about before, depth perception, size, and so on. How does this make us seem that the lady in the front is larger than the girl in the back? It's because the room is diagrammed that the girls are actually about the same size, but the room is distorted.